Assalamualaikum and hi, my name is Farah Aleesya Mohamad Rosdi. My matrix number is 2020626154 and I am from EC1104L. I was given the mini project task of conducting a soil experiment that can be associated with fundamental concepts in soil mechanics and describing the soil in terms of its moisture content, particle density, particle size, grading and texture, field density and permeability. At the end of the experiment, the specific gravity of the soil, the moisture content, the dry density, the permeability, and the percentage of different grain sizes were all obtained. Therefore, in this video, I demonstrate how to conduct those experiments to find the needed data. The first experiment is moisture content. The objective of this experiment is to determine the moisture content of the soil sample. The discussion of this experiment is the moisture content of the soil, also referred to as the water content of the soil, is a measurement that indicates the amount of water in the soil. The ratio of the mass of water contained in the pore spaces of soil to the mass of solid particles present in that material is the definition of moisture content. The natural moisture content provides an idea of the state of the soil in the field. The conclusion of this experiment is the objective of this test, which was to determine the moisture content of the soil sample, was accomplished at its end. At the end of this experiment, the moisture content of the soil was determined. The phase relationships of water, air, and solids in a given volume or weight of the material can be expressed using the moisture content of the soil as the variable of interest. The moisture content of any soil affects the density that may be attained with a specific level of physical exertion. The second experiment is particle density. The objective of this experiment is to determine the specific gravity of soil using a density bottle. The discussion of this experiment is the particle density of the soil solids can determine the specific gravity of the soil by using the density bottle method. The ratio of the mass of an equivalent volume of distilled water to the mass of a given volume of soil solids at a constant temperature defines a substance's specific gravity. The specific gravity of soil was used to assess its porosity and the number of voids it contains. It helps them determine whether or not the soil is stable enough to sustain construction. This is because the specific gravity is an indicator of how durable a substance will be. The conclusion of this experiment is based on the objective of the experiment, which is to determine the specific gravity of soil using a density bottle, can conclude that this experiment achieved its objective. At the end of this experiment, the specific gravity of the soil was determined by using a density bottle. This is because the soil that has been used was fine-grained. The third experiment is particle size grading and texture sieve analysis. The objective of this experiment is to determine the percentage of different grain sizes contained in soil. The discussion of this experiment is the ultimate element of soil are called soil particles, and they come in various shapes and sizes. Soil is assembled from these soil particles. A particle size analysis aims to classify these particles into distinct size range and calculate the percentage by the weight that each size range relates to. The process of determining the particle size of the soil is an important component of the system that is used to classify soils. For this experiment, the sieve analysis method was used because of the distribution of particles which size greater than 0.75 mm. The conclusion of this experiment is the objective of this test, which was to determine the percentage of various grain sizes in present soil, was accomplished at its end. The mechanical or sieve analysis is used to determine the distribution of larger, coarser particles. The fourth experiment is field density. The objective of this experiment is to determine the dry density in situ soil. The discussion of this experiment is the relative density of soil that has been compacted using various pieces of compacting equipment can be measured using a soil field density test. Compaction of the soil means pressing the soil particles close to each other by mechanical methods. As a consequence of the compaction process, air previously contained within the soil's void spaces is forced out of the soil mass, increasing density. Compacting the soil usually results in an increase in the shear strength of the soil, consequently in the soil stability and bearing capacity. Additionally, its composition helps lower the compressibility and permeability of soil mass. The conclusion of this experiment is the objective of this test, which was to determine the dry density in situ soil, was accomplished at its end. The field density of natural soil is necessary for estimating soil bearing capacity, which is required to evaluate pressures on underlying strata for computing settlement, as well as for the stability analysis of natural slope. The fifth experiment is permeability constant heat test. The objective of this experiment is to determine the coefficient of permeability of coarse grain soils. The discussion of this experiment is soil permeability, also known as hydraulic conductivity, is the rate water moves through the elements that make up soils. It can be conducted either Pauling or constant heat test. For this experiment, the constant heat permeability test is a typical laboratory technique used to determine the coefficient of permeability of coarse grain soils that have a high rate of flow, such as sands and gravels. The term constant heat test refers to a piece of equipment that maintains the same relative elevation of the top of the water column, which is head pressure, over the sample throughout the duration of the test. The rate of water movement through soils, measured in meters or centimeters per second, is referred to as the permeability coefficient, or K. The conclusion of this experiment, based on the objective of the experiment, which is to determine the coefficient of permeability of coarse-grained soils, can conclude that this experiment achieved its objective. The basic idea behind the test is to calculate the permeability of the soil by measuring the volume of water that passes through a soil sample in a certain amount of time, and then applying Darcy's law to the result of the measurement.